Alright guys, so this question says sketch the function f for the domain -5 to 1 giving any real value for the codomain where f of x is equal to x plus 2 times x plus 5 times x minus 1 showing local maximums and minimums and intercepts and state the domain and range. Alright, so the very first step that we need to do is go through and find the y-intercept. Now in order to find the y-intercept we make our x equal to 0, so let's go through and write out our rule now. We've got f of x is equal to x plus 2 x plus 5 multiplied by x minus 1, and we'll make our x equal to 0 now, so we get f of 0 is equal to 0 plus 2, 0 plus 5 and 0 minus 1. That's going to get us 2 multiplied by 5 multiplied by -1, which of course is equal to -10. So the coordinate of that point will be at 0, -10. Now what we need to do is go through and find our x-intercepts. So for our x-intercepts, we're going to make our y value equal to 0, or f of x equal to 0. So we're going to have 0 is equal to x plus 2, x plus 5, x minus 1. And what we're going to do is solve for each bracket separately. So we've got x plus 2 is equal to 0, x plus 5 is equal to 0, and x minus 1 is equal to 0. So that's going to get us x is equal to -2, x is equal to -5, x is equal to 1. And the coordinates of the intercepts are therefore -2, 0, -5, 0, and 1, 0. So let's go through now and plot all those points. So we've got our coordinate at 1, 0, -5, 0, and -2, 0. And we'll go through and write out the coordinates just above them. So we've got 1, 0, -2, 0, and -5, 0. And of course at the coordinate 0, -10, so we'll go down here and put in the point 0, -10. Alright, so that's all well and good. We're actually just going through and sketching a regular cubic as we've seen in previous lessons, but now what we need to consider is this part here that's called the domain. So let's go through and think about this. What we need to do is figure out whereabouts the graph is going to start and finish. Alright, so the graph starts at -5 and finishes at 1. So what you can see here is that we've actually got the starting point at -5, 0, because that's what you're going to get when you substitute in x equals -5, and we've got our endpoint at 1, 0. So what we're going to have is a graph that goes up like this and then comes down and then goes back up and finishes here. But what I want to do is just show you how to go about finding the endpoints should these not be at points that we've already got. So in order to do this, we're going to go for endpoints. We've got x equals -5 first of all, so what we're going to do is we're going to go f of -5, and that's equal to -5 plus 2, -5 plus 5, and -5 minus 1. That of course is going to get us -5 plus 2 is -3, -5 plus 5 is equal to 0, and -5 minus 1 is equal to -6. And of course -3 times 0 is 0 times -6 is 0. So therefore the first endpoint is at -5, 0, which we already knew. So we're going to find the endpoint at x equals 1 now. So for endpoint at x equals 1, go through and substitute into the equation now. So you get f of 1 is equal to 1 plus 2, 1 plus 5, and 1 minus 1. That therefore is going to get us 1 plus 2 is 3, 1 plus 5 is 6, and 1 minus 1 is 0. And of course, because we've got the 0 at the end, what we're going to have is it all equal to 0, because 3 times 6 is 18 times 0 is 0. So therefore the other endpoint is at the coordinates 1, 0, which we already knew as well, because we already had our x-intercept there. So now what we need to do is go through and find the turning points. And there's only one way that I've shown you how to do this thus far. We'll come to another way later on in the year. But let's go through now and use your CAS calculator in order to be able to find these turning points. Alright, so the first thing we need to do is go into a graphs page. So you come down to this graph section here, click on it, and then up it will come. Now what we're going to do is enter in the rules. So the rule is x plus 2 multiplied by x plus 5 multiplied by x minus 1. And then we press enter. and that's going to get us our graph. Now as you can see, the graph here doesn't really fit in on our screen, so what we need to do is go through and change the window settings. So we go Menu, Window Zoom, Window Settings, and let's make the window settings the same as what you can see here on our graph that we've got over on our right. So we've got from -6 for our x value to 2 as our maximum x value. Our y minimum value, well, that's going to be -12 to our y maximum is 13. Leaving our x and y scales auto, so we go OK, and now what you can see is the graph that's pretty much what we're going to need to see when we sketch it. So now what we can do is we can go through and find out our local maximums and minimums. So in order to do that, we go Menu, we go Analyze Graph, we're going to go Maximum, we're going to go Lower Bound, we're going to go Upper Bound, and then we find out that it's at -3.73, 10.4. So we go over and we're going to write that on the graph over here at -3.73, so that's around about here, and 10.4 is around about here. And we're just going to write the coordinate of the points, so it's -3.73 and 10.4. Now what we need to do is go through and find our local minimum. So to do that, we go Menu, Analyze Graph, down to Minimum, go over to the left, over to the right, and you're going to get, as you can see, 0.268 and -10.4. So let's go through and plot that point now. So 0.268, which is going to be roughly here, and -10.4, so it's going to be roughly here. Plot the dot, and we'll write it out. So -0.268 and -10.4. And now all we need to do is go through and join the dots. So we know that the graph is going to go up here like so to its maximum point, down here like so to its minimum point. So I'm going to go through the y-intercept and back to here, because we know that it starts at -5 and it finishes at 1. That is, it starts at x-intercept of -5, 0 and the x-intercept at 1, 0. Now let's go back and have a look at what we need to sketch out. So it says sketch the graph between -5 and 1. Now these here are square brackets, so it means they must be included. So what we're going to do is just make it very clear by doing some big dots at the end and this end as well, just so that way it's clear that we know that that's included. And we've also, as you can see, we've got the points written out here, so that's all included. Where f of x is equal to that, so we've actually sketched out the graph where we've shown all the x-intercepts and y-intercepts, so that's done. Showing local maximums and minimums, so we've shown our local maximum here and our local minimum down here. And intercepts, so I've shown all those, and state the domain and range. So our domain goes from, alright, well, what's the furthest x value going across to the left? Well, it's -5, and it's included, so -5. 2, what's the furthest x value going across to our right? Well, it's 1, and also it's included because it's a coloured in dot, so -5 to 1. Alright, our range. Let's look here now, we're going to look at our y value. So to the furthest y value down is actually -10.4, and it's included because it goes through that point. And the highest y value that we've got is 10.4, and also it's included because it actually goes through that point. So therefore the domain is -5 to 1 and the range is -10.4 to 10.4. And that there is how you sketch the graph of f of x is equal to x plus 2 multiplied by x plus 5 multiplied by x minus 1 across the domain -5 to 1, showing all of your x and y intercepts and stating the domain and range. Okay, so it's now time to press pause and attempt the following question, that is, sketch the function f for the domain -2 to 4, giving any real value for the codomain, where f of x is equal to x cubed minus 3x squared plus 4, showing local maximums and minimums and intercepts, and state the domain and range. Remember when you're done to press play so you can check your answers out against mine. Alright, so welcome back. Now as you can see, the very first thing I've gone through and done is I've found the y-intercept by making my x equal to 0. So I've written out the equation of the line as you can see here, and then I've made my x equal to 0. So you get 0 cubed minus 3 times 0 squared plus 4, and of course f of 0 is then equal to 4, so that gives me the coordinates 0, 4, like so. Alright, now what I need to do is I need to go through and find my x-intercept. So for my x-intercepts, I make y equal to 0. Therefore f of x is equal to x cubed minus 3x squared plus 4, and I substitute 0 for f of x. Now I go and I have a look, I've got 1, 2 different types of x, so because I've got more than one type of x, I must factorise. And to do that I need to look for what could possibly be factors. So I've had a look at the number 4 and I've said, I know that 2 goes into 4, so let's see if x minus 2 is a factor. Alright, so to do that I've gone f of 2 is equal to 2 cubed minus 3 times 2 squared plus 4. And 2 cubed is 8, 2 squared is 4, so you get negative 3 times 4 plus 4. Negative 3 times 4 is negative 12, so you get 8 minus 12 is negative 4 plus 4 is equal to 0. Yes, x minus 2 is a factor. So I bring that up here and I've written x minus 2 as a factor. Now because I know that, I can write the 2 out the front and I can write out the coefficients of my function. That is f of x is equal to x cubed minus 3x squared plus 4. Now as you can see, the coefficient of the x cubed is 1. The coefficient of the x squared is negative 3. There's no x, so I've had to put in a placeholder of 0, and I've written plus 4 for my constant there. Now what I go through and do is I write the 0 out the bottom, and you go 1 plus 0 is 1, 2 times 1 is 2, negative 3 plus 2 is negative 1, 2 times negative 1 is negative 2, 0 plus negative 2 is negative 2, 2 times negative 2 is negative 4, and 4 plus negative 4 is 0. Therefore what I can go through and do is write out my remainder, my constant, my x, and my x squared. Therefore I get out the front f of x is equal to x minus 2 because we knew that was a factor. And then when I multiply that by x squared, because my 1x squared, so x squared minus x, because negative 1x, minus 2. So when I multiply x minus 2 by x squared minus x minus 2, I would end up getting my f of x. So I've actually gone through and factorised it now. Now what I need to do is go through and factorise the x squared minus x minus 2. So in order to do that, I look for factors of a negative 2 that add to negative 1. So x minus 2. So negative 2 plus 1 equals negative 1. So therefore I'm going to get x minus 2 and x plus 1 in the brackets. Therefore I get 0 is equal to x minus 2 squared, because this has been repeated, multiplied by x plus 1. And I can go through and solve now for my x-intercept. So I get x minus 2 is equal to 0 and x plus 1 is equal to 0. Therefore x is equal to 2 and x is equal to negative 1. And the coordinates of these points are 2, 0 and negative 1, 0. Excellent. Now what I need to do is go through and find my endpoints. So my endpoints are going to be at the very extremes of the domain, so that it's negative 2 to 4. So it's therefore my endpoints are going to be x equals negative 2 and x equals 4. So I've got to substitute negative 2 into my equation f of x that you can see here. So I get f of negative 2 is equal to negative 2 cubed minus 3 times negative 2 squared plus 4. Negative 2 cubed is negative 8. Negative 2 squared is 4. And then you're going to get negative 8 minus 3 times 4, well, negative 3 times 4 is negative 12. So you get negative 8 minus 12 plus 4, well that's equal to negative 16. So therefore the coordinate of that endpoint is going to be at negative 2, negative 16. Coming over to my endpoint 4 now, at x equals 4 that is, so you've got 4 cubed minus 3 times 4 squared plus 4. Now 4 cubed is 64 and 4 squared is 16. 64 minus 3 times 16, well negative 3 times negative 16 is negative 48. Then you've got your plus 4 at the end there. Negative 64 minus 48 plus 4 is equal to 20. So therefore the coordinate of this point is at the coordinates 4, 20. So what I go through and do now is I plot all these points. So that's 0, 4, as you can see over here, my y-intercept at 0, 4. My x-intercepts at 2, 0, as you can see here, and negative 1, 0 that you've got over here. And I need to plot my endpoints now, and we can see there that that is at negative 2, negative 16, so I've gone along and plotted that, and 420. Now we need to also consider, are those points included? Well, if you have a look up here at the equation, we've got square brackets here and here, so therefore we know that they are included. If it was round, then we'd need to draw a non-coloured in dot or an empty dot. The last thing I need to do is find my turning points, that is my local maximum and my local minimum. So in order to do that, I must use my CAS calculator. And from here I'm going to go down to the graphs page, and I'm going to type in my equation. So my equation is x cubed minus 3x squared plus 4. And I press enter, and as you can see the graph's now been sketched. Now let's just make sure our window represents what you can see going on our graph, so it looks somewhat similar. So we're going to go menu, window zoom, window settings, and we're going to change the window to look like what you can see here over on our graph. So our x min is going to be negative 3, our x max is going to be 4, we're going to leave our x scale as auto, our y minimum, well that's negative 20, our y maximum, well that's going to be 20, and our y scale will be left as auto. Go down to OK now, and what you can see is a set of axes with the graph that looks somewhat like what we've got. Now what we need to do is find out our local minimum and local maximum point. So we're going to go Menu, Analyze Graph, Maximum, Lower Bound, Upper Bound, and you get it at 0.4. Oh great, we've already got that point plotted over on our graph. Now our minimum, so you go Menu, Analyze Graph, Minimum, Lower Bound, Upper Bound, and if I move this equation just out of the way quickly, you can see that that is at the coordinates 2, 0. And I've plotted the coordinates 2, 0 over here. Now of course we knew that there was going to be a turning point at the coordinates 2, 0 because this here, this factor of x minus 2 that you can see over here, well that's been squared, so therefore it means there's a turning point at that x-intercept. The final thing that we need to do now is go through and talk about the domain and range. Well, the domain goes from -2 to 4. And is it included? Well yes it is, because it's square brackets, so it's from -2 to 4 with square brackets. Now the range, what's our lowest y value? Well, it's going to be -16 to 20. And because we know that these points are included, therefore so are the range values. So it's square brackets -16 to 20. And that there is how you sketch the graph of f of x is equal to x cubed minus 3x squared plus 4 over the domain -2 to 4.
Alright guys, so thank you very much for tuning into today's lesson, which was all about domain and range. And in fact it was the very last lesson for this topic, which was all about cubic and chordic functions. So of course, like always, make sure you say hi to your maths teacher for me. Morsey out.